having studied limits and the tangent line problem, we're finally in a position now to study the derivative of a function. Now this lesson, along with the fundamental theorem of calculus, are probably the two most important lessons in any calculus course. So let's begin by recalling from a previous example that we found the slope of the line tangent to the graph of this function at the point 3, -5 by evaluating this limit. So we evaluated this limit as delta x approached 0, and we found it to equal 4. And what that represented is that was the slope of the tangent line to the graph of this function at the point 3, -5. And also recall that these quantities right here, what that represented were the slopes of the secant lines. And as delta x approached 0, the secant lines approached the true tangent line, so the slopes of the secant lines approached the slope of the true tangent line, which in this example is 4. Alright, now we could have done this. Instead of evaluating the limit with the 3's in there, notice how we put the 3's in there. This quantity right here, by the way, is the -5, f of 3. That's where the -5 comes from. Instead of putting the 3's in there, we could have just left x's in there, variables. Just put the letter x in there. Evaluate this limit, and you'll get just a function of x. And then we could have put the 3 into that function of x. Now, this quantity that we get here, this function, is what we call the derivative of the function f of x. And that's what we define down here. So let's take a look at this definition. So we define the derivative of the function f of x to be another function, and we call it f prime of x. And it's defined like this. So we simply evaluate the limit as delta x approaches 0, f of x plus delta x minus f of x over delta x, and that's what we call the derivative, and that is another function of x. Now this is probably the most important thing to note in your first calculus course, and that is that f prime of x represents the slope of tangent lines to the graph of y equals f of x at points x, f of x along the graph of the original function y equals f of x. That's probably the most important thing to note in your first calculus course. That's what the derivative represents. Now, let's also note this. If I were to take the number c and put it in here for x, then of course f prime of c is the slope of the line tangent to the graph of our function at the point cf of c, and the equation of the tangent line is then given by this. So this would be the equation of the tangent line at the point cf of c, right there. And notice that that comes from this equation. Alright, so here we see what we have. This is simply the point slope form for the equation of a line. We have the slope right here, that's our slope, and the point is c f of c. And then you just take the f of c over to the other side and you get this equation. Alright. Now some other notation down here. You will also see f prime of x denoted like this. You'll see it denoted as df dx, dy dx, and sometimes this notation, but not often in our course, dx of f, like that. Now notice, where do this notation, this df dx, where does that notation come from? Well, if you look at our definition up here, this is really the limit as delta x approaches 0. The numerator represents, if you remember, it represents our change in f divided by our change in x. And so as delta x goes to 0, this is approaching an infinitesimally small number, 0, and our top is also going to be approaching an infinitesimally small value, and so we represent this as df dx. You notice in the limit as delta x approaches 0. And if we replace the f with the letter y, y equals f of x, then you get dy dx. Right? You can also think of this as being a change in y, so we could also write this as well. We could put a change in y, and then we get the notation dy dx. So that's where that df dx and dy dx notation comes from. Alright, so that is what the derivative of a function represents. Let's take a look at some examples. So we want to find the derivative of this function, x squared minus 2x minus 8. Then we want to find the equation of the line tangent to the graph at the point 3, negative 5, and then we'll verify our answer graphically. So for the derivative, we have to evaluate this, f prime of x, or dy dx, whichever notation you like to use. Now we just have to put our function in here and here. Now when evaluating f of x plus delta x, remember you have to put the x plus delta x in place of each x in your function. So this becomes and now we just need to clean this up. We'll FOIL this out, distribute the negative 2, distribute this negative, and then we'll get some cancellation, and eventually we'll be able to cancel this delta x in the bottom. So let's see how this works. Alright, so all I did here is we just FOILed out the x plus delta x. Right here it is. Distributed the negative 2, negative 2x minus 2 delta x, and then just distributed that negative, so minus x squared plus 2x plus 8. Now we see that we have some cancellation. That 2x cancels with that one, and this x squared cancels with this x squared. And then this evaluates out to okay, now we can cancel this delta x with the delta x here, here, and here. Only one of those cancels, and this one cancels, and we end up with now all we have to do is delta x is approaching 0. We can just substitute 0 in for this delta x, and we end up with our answer being, and there is our derivative function. So that's our answer. So we have that f prime of x, or dy dx, equals 2x minus 2. There is our answer to part A. Now let's look at part B. So let's find the equation of the tangent line at the point 3, negative 5. Well, alright, we have a point. So for part B, we know that the point is 3, negative 5. We need to find the slope. Well, the derivative gives us slopes of tangent lines. So the slope of our tangent line is going to be f prime of 3, which in this case now we just plug 3 in here for x, and we get back 2 times 3 minus 2, or 4. And then the equation of our tangent line and there is the equation of our tangent line. Y equals 4x minus 17. Alright, so you see how we evaluated the slope of our tangent line? We simply plugged 3 into our derivative function. Now let's verify our answer graphically down here. And down here we have the graph of our function and the tangent line. So the blue curve here is the graph of y equals x squared minus 2x minus 8, and that red line is the line y equals 4x minus 7, and it does look like it is tangent at the point 3, negative 5 right there. Alright, so I invite you to graph those on your calculator to see that this is exactly what you get. Now let's take a look at another example. So let's find the derivative of this function, the square root of x. And then we're going to find the equation of the tangent line at the point 1, 1, and then verify everything graphically. Alright, so we have to go back to the definition of the derivative. And now in this case, we just have to put the square root of x in for our two functions here. Alright, so we have this. Now we have to evaluate this limit as delta x goes to 0. Now, this looks a little funny. We're going to have to somehow figure out how to cancel this delta x down here, because it's going to 0 and end up with an answer. Well, if you think back to the rationalization technique, what we can do is multiply this by Alright, so we're going to use the rationalization technique here. Notice that what we have here is just 1. This is just the number 1. I multiplied by the conjugate of the numerator and divided back out by the exact same thing. Now we can multiply the numerators together and denominators, and we'll see we'll be able to cancel that delta x. So this becomes, now when we look at the square root of x plus delta x times this square root, we're going to get, and then remember the square root of x plus delta x times square root x plus negative root x times square root x plus delta x. They just cancel. And then the final term in the FOIL method is the square root of x times the square root of x with that negative there, and I just get x right here. And then all of this is divided by the product of the denominators, and we don't distribute this out, we just leave it as like that. Now you notice here what we have are these two x's cancel, so they're eliminated. Then what we have is this delta x. We will only be left with this delta x in the numerator, so it will cancel with this one as follows. Indicate it like this, so this and this cancel, leaving me 1 and 1. And what we finally end up with then is now what we can do, delta x is going to 0, we can just plug that 0 in for the delta x. And we're not going to get 0 in the denominator. as long as x is not 0 itself, which we will have to assume. And we end up with, notice when I put 0 in for this delta x here, we get the square root of x plus the square root of x, and so we get 1 over 2 root x. That is the derivative of the square root function. So we can write f prime of x equals 1 over 2 root x. And that is our answer. All right. Just some other notation you might see sometimes for f prime. You might also see this written d dx of the square root of x equals 1 over 2 root x. That's what we just found. Just to get you used to using some different notation than f prime. You might see this written as well, or dy dx. All right, so now let's take a look at part B. So we want to find the equation of the line tangent to the graph at 1, 1. So our point we're given as 1, 1. The slope of our tangent line will be f prime of 1. Now be careful here. The 1 here comes from the x-coordinate right here, right? So that 1 is what we're putting in here, right? The x-coordinate. And when I put that in to my derivative function, I get 1 over 2 root 1, and that of course is 1/2. So there is our slope. Our tangent line is then going to be given by, or we can write that as, and we're going to have negative 1/2, bring that one plus 1, negative 1/2 plus 1 plus 1/2. There's the equation of our tangent line. All right, let's verify everything graphically down here. And right here we have the graph of the square root of x, and the red curve is the tangent line y equals 1/2 x plus 1/2. And yep, it does look like it is tangent to the graph of the square root of x at the point 1, 1. All right, let's take a look at one more example, and I invite you to try this one on your own. So try to evaluate the derivative of the function 1 over x. Then find the equation of the tangent line at 2, 1/2, and then verify everything graphically. So assuming you've done that, I'm going to go through the answer. So our derivative for this function now what we have to do is somehow cancel that delta x down here in the denominator. So if you recall back to limits that we looked at previously, we're going to do some cross multiplying here, or just simplifying this fraction in the numerator by finding a common denominator, or cross multiplying, and then we'll be able to cancel that delta x. So we'll do that as follows. Okay, and then we can clean up the numerator up here. Notice how those x's cancel like that because of this minus. And then I'm going to be left with a delta x in the numerator up here. That will cancel with this delta x down here as follows. So this delta x will then cancel with this one, leaving us 1 and 1 right here after we drop out those x's. Now we will have a negative 1 up here in the numerator up here, and this will then simplify as now we can let delta x approach 0. We can just put delta x right in, or 0 right in for that delta x, Put 0 right in here as we let delta x go to 0. And we get just negative 1 over x squared. And there you go. That is the derivative of 1 over x. So we found that. That's our derivative. And then for part B, the point is 2, 1/2. Now the slope of our tangent line is going to be f prime of 2. And so if I put 2 in here for this x, we're going to get negative 1/4. And then the equation of our tangent line is then going to be like that. And then let's see, that will simplify as negative 1/4 times negative 2 is going to give me positive 1/2. I'll write it out like that, positive 1/2. And then bringing that 1/2 over, another positive 1/2. And so we're getting, and there is the equation of our tangent line at the point 2, 1/2 for the graph of 1 over x. Let's take a look at everything graphically and see what it looks like. So here is the graph of the function. The blue curve right here is our y equals 1 over x. And the red curve down here is our tangent line. Y equals negative 1/4 x plus 1. All right? And yes, right there, that's the point 2, 1/2. And it does look like the line that we found is tangent to the graph of 1 over x at the point 2, 1/2. All right. So that concludes this lesson on the derivative of a function and how to evaluate it.